Hello everyone. Today we will try to dive into the brutal world of software development. We will see what challenges await everyone who stands on the development path, what secrets are hidden behind the big name, the platform, and how to build a hybrid environment with implementation of dynamic stages paradigm. Let's introduce our speakers. My name is Anton, and for 10 years I have been building platforms for engineers and looking for a way to create an ideal world of creativity and software development. Today, I will be talking about nature of platform engineering and presenting our Slack automation solution.
So, good night, I'm Luiz. I've been with Semrush for around 1 year and a half now, working as a software and platform team. I've been working as software engineer for around 15 years, I guess, like with Java, Golang, and some Rust also. Outside of work, I spend a lot of time climbing also, also playing a band. Funny enough is teach me a lot also about problem solving and collaboration. And I'm gonna let you with my friend.
Our presentation contains two parts. In the first part, we will know something about Semrush and enterprise solutions. I'll show you the dark side of software development, explain who is the platform engineer, and describe how to build a platform with power of Slack application. For the second part, Luiz will walk you through dynamic stages, our solution for isolated test environments. He'll show you architecture decisions, how we made it incredibly fast with smart database seeding, and what the real impact on our development workflow. Couple of words about our world. Semrush is a global platform with extremely huge range of products and tools used in many areas of marketing and analytics. Me and Luiz are working in Enterprise Solutions Unit, which is focused on large organizations. Every day, we are facing and solving several challenges of enterprise software development. Together with 12 teams, we are building a set of products, including SEO and AO, ready-to-use solutions for many enterprise customers. Our teams are writing in 5 programming languages, including Go, Python, Scala, JavaScript, and TypeScript. We have many different components and integrations. We are integrating internally with Semrush systems and externally outside of our infrastructure. Due to real complexity of our system, we build hybrid architecture with simple microservices, ETL processes, low-code workflow, and very powerful no-code query engine. In our development, we combine code, low-code, and of course, AI technologies to give the best solution for our clients. Now, let's make a pause and deeply analyze this expression. Difficulties and problems do not always exist in reality. They often arise where there are only complications of your vision. I believe that the secret of ideal software engineering process is hidden inside these words. My interpretation is that in the world of information technologies, the bulk of problems and difficulties are not related to their real nature. It's just an illusion caused by a series of unconscious acts occurred in inappropriate circumstances. This is a typical software developer nowadays, tired and overwhelmed, with head full of worries and nightmares. First nightmare is about incidents. I really hate situation when production is on fire and no one knows how to fix it. Imagine holidays, and you are going to walk someone in mountains, but then you saw alert from your monitoring system because someone deployed something in the late Friday evening, and now you need to help with the rolling back these changes or providing hotfix. Before delivering new features, we need to test them. But where we can do it? Usually, such single environment called release candidate. And believe me, it's a really bad experience when this environment is broken because of wrong data migration or when one feature is not compatible with another. Slow tests, slow builds, slow deploys. Unfortunately, this is very often case in our life when we need to wait our continuous processes. This waiting can be very critical, especially when you're trying to prepare a hotfix to production. Logs, metrics, traces, three main things which you always need when you're investigating the incident. But where to find them, and what is more important, how to filter them by your specific broken case. Overall, life of software developer is not easy. And to make this cat happy, we are building platform and using best practices of platform engineering. Platform engineer is a high-skilled expert and developer who went through the whole development path and knows the system from inside of it. In this role, there are living two souls, site reliability engineer and DevOps engineer. Simply speaking, it's a wizard who casting light and sometimes dark magic to build a platform for developers, engineers, managers, and QA to make their life easier. I have selected main spells from magical grimoire of platform engineer. Automate everything, always and everywhere. We must do as less as possible. If process can be automated, it should be automated. Building the platform is feeling like making order from chaos. You're trying to structure things, make them ordered. Somewhere you need to split, somewhere you need to combine. Flexibility of Bamboo is helping us finding suitable solutions in many different challenges. If you like a technology, but it does not cover all your cases, you can just take it, fork, and approve. That was a real case in our experience when we forked open source library and applied some patches in there. Coding is not the only thing which platform engineer is doing. A huge bunch of work is about talking, persuading, and finding compromises with a lot of people. We believe that all environments should be fully isolated, immutable, and dynamic. Mindfulness. Mindfulness is about balance. Mindfulness is about focus. Mindfulness is about order. To make order in someone else's head, we always should have order in ours. Sometimes people are expecting from platform engineer to be a production watcher and fixer during day and night. This is not the main purpose of platform engineer. Of course, we care about our system stability, but for us, it's more important to help teams with making features and fixes without distraction and focus it. Platform is the best friend to achieve our goals. Current platform in enterprise solutions contains many different tools, and one of them is our Slack automation bot. This is our buddy. Bot is living in Slack and helping teams do many different things. On the screen, you can see commands which our bot is processing. I want to highlight that bot is fully integrated with all our pipelines and important Slack channels. Now, let's look on the functions. With commands, we are releasing projects, getting information about deployment history, implementing our required policies, and managing dynamic environments. Bot is notifying about all important processes, including releases, deployments, duty shifts, and many others. To get actual information about GitLab entities and duty shift calendar from our incident management system, bot is executing periodic scheduled jobs. We didn't want to make a large complex system. For now, bot is just a set of small Golang services integrated together with the power of Temporal. Temporal is our workflow execution engine. Each bot command is a separated workflow processed by the temporal and executed by worker module. In addition to temporal workflows and jobs, we are using temporal nexus. Nexus is our remote procedure calling engine, which is encapsulating cross-module communication and executing fast synchronous operations. Nexus also has many important features out of the box. For example, circuit breaker and automated retries. To develop the boat, we use Mees and DevSpace together. Mees is a task executor and package manager. We are running local tasks with Mees and also implementing pipeline actions. DevSpace is our team internal approach to work remotely from inside Kubernetes pod with full access to cluster environment. But we are planning to migrate from DevSpace to telepresence because of network and performance issues. So let's make a short pause and reflect about what we know. Software development is not only about vibe coding and smoothie drinking. That world full of nightmares, monsters, and creatures. Platform engineers are wizards who are making IT cats happier with magic of platform. And Slack is not just a chat, but also a very powerful foundation for building automated workflows and processes. Now, I want to give a word to Luiz, and he will present our dynamic stages solution.
Hello again. So tonight I want to talk about a problem that every people works with software probably would recognize. So I want to share with you how we build dynamic stages in a way that every merge request that we open, it gets its own isolated environment. So let's imagine a scenario that probably you recognize. So imagine you have many teams and all working on microservices platform. So everyone needs to test their changes in an environment like a production-like environment. So you're ready to test, but someone else is using this environment. So you wait, and you have to wait a lot of your time waiting. Your test data is mixed with many other developers' test data. So good luck trying to debug this. Your logs are buried in thousands of lines of other people's tests. Someone runs a migration, everyone's environment is broken. You push a change, you wait hours for the shared environment to be free, someone deploys something on top of your changes. So this is the daily life and reality with shared environments. So I personally call it waiting-driven development. So we ask ourselves what every developer could have their own production-like environment. Quick context about some naming that we use. That, I mean, it's not common, but I would just want to make sure that you can understand. So we work with something that we call blueprints. So like blueprints basically are a collection of services and the dependencies. So for example, you have 5, 7 Golang applications, you have a database, you have a Redis cache and PubSub, and so on. So basically we call this collection of things and dependencies, we call blueprints. The biggest question we faced was how do we create many isolated environments that are fast to spin up and give a kind of real production-like experience. In our production environment, we use GCP. So we have, for example, Cloud SQL, we have Cloud PubSub. Those are expensive tools, right? And share it between many applications, and many people are using usually this environment like a staging or RC environment. So we cannot just spin up 10 instance of Cloud SQL. I mean, you can do it, but it's expensive, and like we don't want to do it, right? So for stages, our option was to use pod-based alternatives. So for example, for Postgres, we we deploy in a stateful set that runs on our Kubernetes. It means that every blueprint and every service that has a database runs this their own dependencies and memory so depending what we use, but for Postgres it's pod-based. For PubSub, so in production we have Cloud PubSub, and lucky enough Google provides an emulator that works really well. So it's API compatible and it's quite fast, so it covers all of we need for our tests. For temporal, we use a containerized development version that also runs on a pod on our Kubernetes, so we use minimal resources. So you may think that, okay, like this doesn't reproduce production, but well, not 100%, but for development and testing, I guess the fast feedback beats perfect replication of production environment. So we always think about developer experience. So we want to be close to the developers. Like when I joined Semrush, actually I was at the developer team. My whole life I was a backend engineer, so I know this kind of pain. So I want to show like quickly how this looks like from a developer's perspective. So basically you open a merge request and you add a label related with what your blueprint. So you can do it or not, but so when you add a label, it triggers the pipelines to create your stage. So we also send some metadata related to the stage, like the blueprint name, so the merge request ID, who created the stage, many other information that we can use later for metrics. Or you can even request your staging on demand using the cockpit bot, the bot that Anton mentioned before. Or you can just manually trigger on the pipeline. So it's quite flexible. So we made also in a way that, so we want people using the bot. So we have more options on the bot than on the pipeline. Usually the pipeline is just default values, ephemeral, but as you can see in the image, I don't know if it's big enough, but there are some other parameters that you can send using the bot. So then around 5 minutes, 7, like we're not counting the tests and the other things that runs on the pipeline for now, but you would have a live URL with all the service running, with your front end, everything isolated, your database loaded with realistic data, data from our RC, what we have closest to the production, with all the dependencies, so ready to test. And what makes this so fast? If we think about traditional database seeding or like manual SQL scripts, it's quite difficult to maintain this, right? Like this, to keep this data consistent between all of the service. So, and also a lot of time to set up this kind of environment. It's so painful. So we treat database dumps as container images. So then time to time we have this job that connects to our RC environment. So we connect to the read replicas. So it's completely safe because it's on the read replicas and there's no impact on RC. So I want to highlight that our RC environment is super important for the product team also, so they validate a lot of the features there. So we treat RC now, and I think we are treating even more after this kind of solution close to production, so we don't want to break this. Like if you break, maybe if you break RC, I think people will realize before if you break production, because people are there. coming back to the process. So, and then after this process, we export all of the database to compressed SQL files, and then we build a Docker image with those files baked in, and then in the image, and then we push to our registry. So it means that the stage code with the same ID would matches the latest image from our database completely. Just to tell about timing, so a full production database for around 3 gigabytes and maybe 8 schemas, 140 tables. It takes 16 seconds to start. So it's really fast than do it running the scripts during the stage creation, right? So that's why we bake this image with all of the scripts before, and it runs also in parallel. So it's super fast, it's consistent. Everyone gets the same prod quality data, and you can also, for example, skip the seeding part. So if you want an empty database, there's also this option. Like easily, you just send a flag, and then you have everything empty. This is why the database startup is super fast. Yeah, now here is a kind of critical architecture decision, like who controls what. So we need stage to work correctly without forcing product teams to understand what, like the internals of stages, right? So what we do, like we split the ownership, and so product teams they create a file on their site that we follow a convention, like because we use Helm, so we have this value stage.yaml. So on their sites they can, for example, do some optimizations. I don't know, they want instead of 5 replicas, they want 1, or they want to decrease the memory because maybe it's not important, or disable even outscaling, or enable if you want the test. So they know their service best, right? So and they don't need to know how stages are named, or where it runs, so like with namespace, or how the service communicate. So we control that in our stage repository. So we have a parent descriptor file template that defines the communication patterns, namespace, service discovery, and all the topology. So then when we deploy, we merge all of this configuration with strict priority. So for example, the parent values, they always win for namespace, for example, because we don't want to risk that someone would try to deploy this in a namespace that we don't have the control. Like we control also the, not control, but we are responsible also for the budget from the namespace. Like for naming, for inter-service communication, it's after this we apply the optimizations on the file. We also look to RC for some default environment specifics that the service may have. And I mean, the benefit of this is like if we change once in the parent template, it affects all the stages, so no stage rules leaks to the service repository. So we didn't want this, right? We wanted stage to be transparent. Yeah, so then product teams, they optimize their resources. Platform team controls topology, so proper separation of concerns. Yeah, front end. Okay, front end is a separate repo from the back end. So I can see that people say, okay, this may be a problem. So how do you test backend and front-end changes together in an isolated environment? So by default, when you create a stage, we use the less stable version from the main branch. Easy. But sometimes you need to test coordinated changes, right? So you need to test some breaking API changes plus corresponding UI changes. So the solution for this, we have an optional flag that you can also specify the merge request ID related to the front end. and both stages get deployed together at the same isolated stage. It means that also the front end, it's also isolated. So front end team owns their CI/CD, they build their artifacts, we just consume them, put them together, so the same model of isolation applies here. So team autonomy plus flexibility, like cross repo testing when you need, stable defaults when you don't. So what changed for the developers? I want to bring some numbers, but also say that before, we have a lot of waiting for the environment access. Myself, I felt this, and also searching through thousands of logs, lines from other developers, migrations breaking everything in RC and you waiting someone to fix, fear of test, risk changes also, because as I said, the RC environment is super important. And I remember me as a new joiner was like, okay, I don't want to break this environment because if I break, I'm gonna have some problems. So then in the last month, this is like a fresh data. The last month we have around like 104 stages created. So this over 6 stages per week, 9 stages per day, so around 6 teams using this. So 0 waiting, your logs only. You can break whatever you want. If you want to test migrations, you can want to break your database, just break it. And test with quite realistic data also, right? So this is a problem, like you may think that we need many pre-data to do the tests on Semrush. Like we work with data, so it's really difficult if you want to try to simulate this. So it's a really good option to have this data coming from an environment that people know how to test things, and you can just duplicate this. For me, like the real benefit of this is, as I said, like complete isolation. Any database change you make stays on your stage. Multiple developers can test data changes at the same time. And that question that who broke RC, we never hear it anymore. Maybe sometimes still, but everyone can work in parallel. It's safe to experiment. And the bugs can be caught in stages and not in shared RC. Really quick technical overview of the stages CLI. It's written in Go, so there are 3 main commands that create, that also updates. There is the dump command also to create the images, and destroy. So it's really simple, like thinking about developer experience. We want to make the interface also fast. We use Helm for chart management and templating. We use Soaps for secrets and GitLab pipeline for now to run the jobs. We are talking about also to remove the part of the pipeline, so then you can also run locally. But thinking about MVP, this is what we could do. So one command, it does everything, right? So it downloads all of the OCI charts and merge all the configuration using that smart priority logic that I mentioned, deploys the infrastructure and all the services. So what we learned building this, this is my opinion, maybe our team opinion, but good enough beats perfect. So if we think about on our pub sub emulator, it works great for most of the cases until now. Temporal dev server also covers all of our workflow testing needs. The Postgres pod-based with realistic data, what we have on Cloud SQL is Postgres, so basically it's the same. They have some other optimizations, but it's the same, so it works as a production. I mean, we know it's not perfect yet, but we focus on MVP, and adoption. We wanted people using this, so people are using, are breaking, and then we are incrementing and involving the product. This is how we can identify the problems. Another lesson, developer experience drives adoption. So make it simple. It's one command. We also did the first whole implementation on the product team side. That also makes something like easier for adoption. Make it fast. I mean, we're still improving. We are thinking about also in other ways to make it faster. But again, with this already running, with people using, it's easier to just continue involving and spending time because people can see the value of this. Make it reliable. Yeah, so we have some automated cleanups, for example. We have the auto creation using the label. We have some channel monitoring. We are also I'm constant there at the stages channel, just asking questions, trying to help people. I have a problem with my stage, so I break, I build, delete everything, try to find the problems, but we are really focused to make this in a way that will be close to perfect. So then the developers, they will use it. I mean, the vision for this product, make the dynamic stages the standard for the whole company, available on demand whenever the developers need them. Every team uses using this daily with zero friction. Yeah, so I think I hope somehow we could help you to understand the importance of isolated stages. And of course, we are open for some questions and to go maybe even a little bit more technical after all the presentations. If you want to see some code, we have the laptops there also. Yeah, and that's it. Спасибо.